we're going to dive into the rooftop unit training. Now, this is broken up into sections. So first, we're going to talk about the new refrigerant. I don't know if anybody's familiar with that. We're changing refrigerants. Actually, I take that back. We already changed refrigerants. So we're going to get into that. Then we're going to break it down into, we're going to do blowers first, the blower section first. We're going to do the heating section, the cooling section. Then we're going to get into economizers. We're going to talk about programming economizers and so on. And then a little bit about startup. So we do have a long way to go with this. So please feel free to stop and ask questions. All right. The more questions, the better the class. Okay. Because we do rely on you guys. It's obviously the interaction we get with you guys definitely makes for a better class. So please feel free to speak up. This does not take the place of reading the instructions. All right. I know not all of us read the instructions from cover to cover. Myself, I will admit I am one of them. However, with all brand new equipment coming out, pretty much everything we have with refrigerant in it is changing or has changed. So no matter how sure you are, you know how something goes in. Especially with this new equipment, you want to read the instructions because there's going to be new regulations, there's going to be new requirements, and it's in those instructions. So we want to make sure we read those. The BRYANT Service Tech app. Does everybody have the BRYANT Service Tech app on their phone? If not, you should download it. It's called BRYANT Service Tech app. And you don't need to have an account. You can enter as a guest, and you can scan the barcode off of any piece of equipment, humidifier, rooftop unit, and it'll pull all the literature up for that piece of equipment. So if you work on a rooftop unit and the installation instructions weren't left behind, and you're trying to figure out what the gas pressure max is or something, you can scan that barcode and pull it up. So it's pretty helpful. Okay, so that little disclaimers on every slide. So PURON Advanced. Now, for us older guys who were around when we brought PURON in, of course that's the carrier BRYANT name, PURON, but it's R450 or R454B, which most of the industry is going to, except the Daikin family, which is going to R32. All right. So we're not going to get too in depth in those today, but we're going to focus on how they're going to change our lives with what we're doing with rooftop units. So the PURON Advanced is the 454B. So just give you a heads up on how all this worked. As of January 1st, 2025, a month and a half ago, we can no longer produce R410A equipment for installation in package equipment, rooftop units, splits, mini splits. Okay, so package units would include like geo units. It would include through the wall units. So all of that production stopped January 1st, 2025. Okay, so already we can't make it anymore. All right, so the 410 equipment is gone. All right, now we can sell through rooftop units. We have a 3-year sell through. So if they stop making it in 24, we can sell it in 25, 26, 27. Okay, but you will start seeing the new stuff phase in. Splits, including commercial splits. We have a 1-year sell through. Okay, so we can sell it through the end of this year. Okay. Mini splits, same thing. We have a 1-year sell through. So what all this means is in the next year, like every piece of, like I said, air conditioning equipment we sell is changing. Okay, because we're changing refrigerants again. So just to give you a brief what's going on with it, you might not even know this all happened, but in December of 2020, AIM Act, drawing a blank. The AIM Act was signed, which started the phase downs of high GWP refrigerants, global warming potential. Okay, so you'll hear this term GWP, global warming potential. So if you rewind back into the 90s, we were worried about ozone depletion, right? So we got rid of R11, R12, R22, the chlorine. So now they decided that the HFCs that we're currently using, 410A, 134A, 404, 407, all the 407s, all the 422s are HFCs, and they have a high GWP, global warming potential. So 404 has a GWP of over 2,000. CO2 has a GWP of 1. It's the baseline. Okay, so that's where they start. So CO2 is our main greenhouse gas. So they say the 404 is, or 410A rather, is over 2,000 times as bad. So we had to get it down under 700, GWP of 700. And anyways, the phase down started in 2022. They cut production of 410A by 10%. In 2024, we brought it down another 30%. So in 2024, production of 410 went down to 60% of what it was in 2020. We haven't seen a huge price change yet in 410A, but we will. Okay, it's coming. The end result is 2036, we want to have it down to 85% of what it was in 2020. So this phase down is much faster than our last one. Because R22, we had a long period of time to phase it down. Okay, for you guys, you younger guys who are going to be around for a while, you're going to do this again in about 15 years. All right, so this is not the last time we're going to phase it down. So just a quick look at what this is. So 410A, PURON, 454B, PURON Advanced. Like I said, everybody except the Daikin families is going to 454B. GWP of 466 as opposed to 2,000. It is what's called an A2L, though. Now, you guys have heard that term, I'm sure, battered around lately. An A2L, it's slightly flammable. Okay, we'll talk a little bit about that. So, when I look at propane, butane, gasoline, everybody in here has or seen some knucklehead like myself light a fire with gasoline, and you get within 10 foot of that pile of wood with gas on it, and it ignites, right? And it, woof, you lose your eyebrows. That's a fast spread ignition. Okay, it didn't take much to light it. Okay, so gasoline is way off here. So this is the burn velocity, the rate at which the flame spread happens. You know, again, if you picture gasoline, you know, that's way over 50. Okay, and this is centimeters per second. So you got some visual of how that spreads. Okay. If we look at 410A, it's not flammable. It has zero flame spread. 454B is just across the line from 410A. So it just falls into the flammable category. So they had to create a whole new grouping for it. Instead of A2, it's an A2L, because an A2 is flammable. A1 is not. A2L is slightly flammable. So the burn rate is less than a half a mile per minute. So the average person walks 3 to 4 miles per minute. Or per hour, rather. So you can outwalk it. So it's a very low flame spread. And if you look at the two side by side, it's just across that imaginary line, making it flammable. It takes a flame to ignite it. A spark won't ignite it. Okay, we need a large quantity of it. Okay, so what do I mean? We all have taken a combustion class. We talked about lower flammability limits or low explosive limits. Propane has a LFL, lower flammability limit of 2%. So I'd need to fill this room with at least 2% propane to make it ignite, right? Anything less, it's not going to ignite. Natural gas is about 5%. So I would actually, if you figured out square footage of this room, I'd need a lot of propane to get this room to 2% to where it would ignite. This stuff is about 12%. Okay, so remember the LFL, because you're going to see that written all over the place. Lower flammability limit. It has about a 12% flammability, meaning I need to fill this room with at least 12% 454B before it'll ignite. If it would ignite. Once I get to that level, a spark won't ignite it, a flame will ignite it. Has a very low flame spread. And if you take the flame away, it goes out. It can't sustain ignition on its own. Okay, so you get some idea what it means, slightly flammable. It is not propane. It does not contain propane. If you look at propane, it's way over here. Okay, that has a very high flame rate, flame spread, and a very low ignition point. Okay, so it's nothing to be afraid of. We do need to be cognizant of the fact that it is technically flammable, but it's really hard to ignite. I would suggest you Google A2L flame spread test, and you will find 5 or 6 videos there of guys actually trying to light it, and you'll see what I mean. So it's not like we should be afraid of it. We need to be a little respectful because they've gone through all this, that it is flammable, but it is, again, like barely flammable. So, yes?
Will the BRYANT equipment have reverse threads?
No.
Okay.
No.
Just tanks, right?
Just the tanks are reverse threads. Yeah. Yeah. And again, what is everybody else doing? I don't know, but the mandate is the tanks have to be reverse threads. Why? Because before you hook up to it, you're going to put an adapter on there. What's the point of that? Because you know when you put that adapter on it, it's a flammable refrigerant. It's not 410. Okay. The tank will also have a red stripe on it. Okay. So it'll be really obviously marked that it's a A2L refrigerant. So again, 450 or 410A over 2,000 GWP, 454B 466, R32 675. Now, why did the Daikin family go to R32? Who knows? But they did. So now, if I look at the composition, I don't want to get into this too depth, but 50% of R410A is R32. 454B is 68% R32. So the point is, you've been working with R32 all this time. As long as you've been working with 410A, you've been working with R32. You just have a little heavier amount of it. And then we have R1234YF. Has anybody heard of that? If you got a car that's newer than about 2016, that's what's in it. Okay. So yeah, your car has an A2L on it. Okay, so we've been working with it. Nothing to be afraid of. R32 is just pure R32. It's 100%. You can't mix them. But the good news is if your helper screws up and puts 454B in your R410 recovery cylinder because he didn't listen, it's 50% R32, so it's not dangerous. I can't use it if it's mixed. We shouldn't mix it, but it's not a dangerous mixture if it gets mixed, okay? Because, again, 410A is a big part R32. Okay, so charge limits. Now, there's limits on how much charge we can put in these. This is all part of the new code. Okay, under 4 pounds, I don't need to do anything special. So we will have some small patch equipment that does not have any mitigation system on it. A little through-the-wall stuff, like P-tacks, things like that. So they hold less than 4 pounds. Splits can hold less than 4 pounds, right, depending on how long the line set is, but they can also hold over 4 pounds, so they'll all have the mitigation system we're going to talk about. We live here at M2, which is 4 pounds to 34 pounds. So you think about what you work on during the day. You don't work on too much that holds more than 34 pounds. Okay. This is where we're going to live. Anything from 34 to 170 pounds will require some other things, the audible alarms and such like that. But this is where everything in rooftop units we have is in that category. Okay, so we're going to have something called a dissipation system. The industry calls it a mitigation, but Bryant Carrier call it dissipation, okay, because they have to be different. So what exactly does this do? So remember that lower flammability limit? Even though we can't ignite it except with the flame, until we get to the low flammability limit, it won't ignite. So we never want to let it get there, okay, as a precaution. So everything with an evaporator will have a sensor in it, okay, and it's looking for R32 from what I'm told. So propane, butane should not set it off. Other chemicals aren't supposed to set it off. So it's set at about 20% of the lower flammability limit. So the lower flammability of 454B is about 12%. So it's looking for 20% of that 12%. So it's a very, very small amount. So what it'll do is if it detects that, okay, hey, I got a leak, it's going to shut the heat off, it's going to shut the air conditioning off, and it's going to turn the blower on. Okay, what's it doing? Because what it wants to do is dilute that refrigerant throughout the entire space. If we dilute it, we can never get to our 12%. Even if we did get to 12%, we still can't light it anyways, but it's really hard to light. So that's what it's doing. Okay, so we're going to talk about that first. So now, like I said, everything we sell except some of the small package stuff under 4 pounds is going to have this. Everything except for the ductless are going to have the same board in it. Okay, this board here I actually took out of the case, actually comes with the new split coils. The rooftop units is already installed, so you don't have to do anything special for this. Okay, this is already installed in the rooftop unit. Okay, so you set the rooftop unit, this is already there. However, there's a test you're going to have to go through with it. Okay, this is a required test. We'll talk about that. So the sensor's pre-mounted. We'll see in a minute where that is. It's right below at the base of the evaporator. And again, what it's going to do, if it gets to 20% of the 12% leak rate, which is a small amount, turn the heat off, turn the air off, turn the blower on. Okay. Now, if you're in a commercial building and the blower's running all day anyways, it will probably never go in dissipation because the blower's running. All right, so just going to dilute it. So the sensor you can see mounted here at the base of the evaporator. Okay, and that's coming from the factory. And then you can see the dissipation board on the small chassis units is here, right inside the blower, the filter compartment to the right of the filter. All right. You can see it here on the smaller units, there in the larger units. Okay, that sticker you see right there is the fault codes for this thing. Okay, it has a yellow light that's on constantly, means everything's good. Different flashes will tell you it's mitigated, or it has mitigated, the sensor's failed, or so on. So we'll look at that a little bit. Yes.
So then that sensor sits behind the filter rack?
Well, yeah, it would be behind the filter rack. It's a good question. It's supposed to be. It's not supposed to be affected by the moisture by the evaporator. Okay. But again, time will tell. Every time we add something new, we have to see. So, but it's not supposed to be affected by moisture from the evaporator. It's not supposed to be affected by gas, propane or natural. It's not supposed to be affected by aerosols. You know, so other chemicals can get sucked up in there. Okay. So, the little status light. Okay. So here's the codes. Solid is good. A solid light is always a good sign, right? Solid. When we talk about the rooftop units later on, solid light's good. We like solid lights. If it's blinking, it means something happened. Okay. So if it gives one flash, it's exceeded that 20%, it's mitigating. Okay. Second flash, the sensor failed. So if you get a bad sensor, it's gonna tell you, and it's gonna put it into mitigation. So your customer calls you and say, the blower keeps running on that unit down there. All right, so that means it either mitigated or possibly we got a board, or a sensor failure. We'd go out there and check it. Okay, so that's what would happen. Normal mitigation after leak, no power to G terminal, fault on sensor, test button stuck, wirings are inverted, or there's a short. Okay. The codes will clear, so what'll happen, it'll go to mitigation if it senses that, okay? And after the refrigerant's cleared, it'll mitigate for 15 minutes, and then it'll go back into normal operation. The code will clear, but you can use that button to recall the code. So if you go back there and say, well, this thing's not working, it's out of refrigerant, and you go back and look, well, it's mitigated 3 times. Okay, that explains it. Okay, so just so you know how it works, because one of the big panics I hear the first time we give this class is, well, it was -6 at my house when I left the house this morning. You got a rooftop unit, the heat shuts off and the blower's running. Great, right? Because that dampers, you got your minimum position open and you're bringing all that nice cold air in the building. Okay, so I want you to see how this all works. So once we reach 20%, Y1 or W1 will open. Again, you do not have to wire this. This is all done internally. The blower will come on. The G relay will close. After 15 minutes of dissipation, if the level dropped below 20%, it will go back into normal operation. So the heat will come back on, the cooling will come back on. So if it dissipates within 15 minutes, it'll clear and go back to normal operation. In heating mode, after 10 minutes. So in heating, if it dissipates, it'll go back into operation after 10 minutes. Now, once that blower comes on, unless you got a gusher leak, it's going to clear it. Okay, so now, if the sensor still detects refrigerant after 15 minutes, so it goes in mitigation, and 15 minutes down the line, it's still sensing a leak, it will assume the sensor has failed, it will leave the blower run continuously, and it will let the heat come back on. So the longest it can go into mitigation is 15 minutes. Okay, but the blower will continue to run. So, you know, the idea there is so the end user tells, hey, you know, the blower hasn't shut off on this thing in 3 days. Okay, then you know there's a problem. Okay, but the good news is the longest it can stay in mitigation is 15 minutes. So this morning, it would have been no heat for 15 minutes, and then it would have went back in operation. The only difference was the blower would run all the time. Okay. Okay, some of the other changes that have gone on. The contactor, you'll notice the contactor is going to have a cover over it. So like now our contactors are open, you can push that bail in by hand, right? You can manually operate that contactor. It's going to have a cover on it to keep a refrigerant from accumulating under it, and there'll be a hole so you can use your meter lead to activate the contactor. Okay. Now, You go out to a job, brand new rooftop in it, contactor fails, and you don't have the one with that cover in your truck. And you say, oh, screw it, I'll just put the regular one in there. You might want to think about that, okay? Because that leaves you open for a lot of liability. All right, so you don't want to change things. Now, what I'm sure is going to happen is all of our replacement contactors are going to go to this because I don't need them on the 410 units, but it's not going to hurt to put it on, right? Some of the other things you're going to see is the braided covers on like the compressor wiring. Some of the other wiring to prevent from pinching it. Well, if it's hard to ignite, why are they doing all this? Well, they're covering their butts is what they're doing. However, and we're, again, I don't want to underplay for the A2L, but, at the other time, I don't want to be afraid of it. But when they put stuff like this on there and we take it upon ourselves to remove it because we didn't have that contactor, and there's a fire in that building, regardless if that caused it or not, they're going to find it. All right, so my suggestion is put that contactor back in. Don't eliminate this thing. Okay, don't eliminate this board. Okay, because one of the trainings I've done, and we've done a ton of these in the last 6 months. Well, first question on somebody's mouth, well, how do I bypass that? You probably shouldn't. Probably not a good idea. Okay, so some of the other things. Now, we deal with the state of Michigan, right? State codes, BOCA, building codes, National Fire Prevention, NFPA. How about DOT? Every time you get in your truck, whatever goes in your truck is regulated by DOT. So there's a lot of regulating agencies, okay, that we deal with. Again, I don't want to go too in depth on this on 32 or in 454B, but there are some new rules. 4 years ago, we couldn't use a A2L refrigerant because the building code wouldn't allow it. So the BOCA code was rewritten to accommodate it, and all 50 states accepted it. Michigan accepted it last spring. However, if you call your local inspector right now, has anybody talked to their inspector about 454B yet? Most of them are going to scratch their heads and look at you. They don't even know how the state code's changing yet. So I'm giving you the information I have right now. Okay, but it's going to be up to you guys. You're going to have to get with your inspectors as they start to figure this out. What's going to be required. So some of the things we do know. We can't have any type of ignition source in our ductwork. Okay. If I do, say electronic air cleaner, I have to have an air switch on it. Heating elements. Well, heating element could be a heat source or an ignition source. Ours are not. If you look at the heating elements for the rooftop units, they are not ignition sources. They're rated so. However, what happens when we go to mitigate it? If it detects a leak, it's going to shut the electric heat off anyways, right? Okay, so we can't put anything in there like that. When we look at a space, in some situations, we may not be able to use ducted or central returns, right? A lot of commercial buildings, we use the ceiling space as a return. We might not be able to do that in some cases. Again, we'll have to see how the code unfolds on this. So we might, in some cases, actually have to directly duct everything, including return, to the space that it's serving. Okay, again, we don't exactly know how that's all going to fall out. So we'll get into the troubleshooting and this stuff on this as we get further down the line. We get an air conditioner. We'll talk a little bit more about it. But any questions on this before we move on? Anything at all with the A2Ls? Okay, you do have to have fire extinguisher in your truck now. That is a DOT requirement. You don't need to placard your trucks unless you have carry more than 440 pounds of A2L in your truck. Somebody asked about the tank. The tank does have a reverse thread on it, so you're going to need an adapter. It's got a red stripe on the tank. The recovery cylinder has a red stripe on it. The unit still has 1/4 inch flare, so we'll talk about tools when we get to that part. But your hoses you currently use will work. The only thing backward thread is on the tank itself. Okay, so the 582K, which that's all we have now, so you guys are probably used to that blue blower there that Dave's leaning on. That was the 582K. You'll notice the model number is now going to change. Do you think you're Vanna White over there? We went from a 582K to a 582L. Not much else in the unit's changed. So when you get the unit, it's not going to look any different, except it's going to have a bunch of safety stickers on it, and it's going to be a 582L as opposed to 582K. Pretty much everything else is not going to change. Okay, so as they're going to go, so between the three chassis sizes, 582K, which was 3 to 28 ton, is now going to become 582L. Okay, the 559 and 547K, same thing. But the 582K is 99% of the units you're going to install. The other percent would be the 581, which is the preferred. So if you walk up on a really nice unit and it's got latches and everything on it, that's the 581. But internally, it's all the same components. So, okay. So we're going to dive into the rooftop units themselves now. Let's see if you have any other questions. Like I said, we're going to return back to troubleshooting on this thing when we get to that, the air conditioning portion of that. So the first part we're going to dive in is to the blowers. Okay. So we have the ASHRAE 90.1 2016, which says if you have over 2,000 CFM blower, it needs to be 2-speed. All right, because in a commercial building, we got to have the blower running all the time, right? That's by code. You have to have circulation all the time. So what this code said is, well, if we're running the blower all the time, it causes a lot of electricity to run that blower at full speed all the time. So we're going to run the blower at a lower speed for circulation. That's what this code said. So if you're working on a 5-ton or smaller, it's going to be a single-speed blower. If you're working on a 5-ton or bigger than 5-ton, over 2,000 CFM, it'll be 2-speed blower. So when you walk up on one of our rooftop units, and if it's the older 580, going back to about 2017, it's got a VFD in it, right? That VFD is there to make 2-speed. We'll get to that VFD. This blower here, okay, the Axion or Bluon, as our carrier brothers would call it, that's running on a DC signal, but it has 2 speeds. All right, so it's running at 2-speed, low speed for circulation, first stage cooling, high speed for heating, and second stage cooling. So this is the whole reason that was all done. So when you're wondering, why did we do all this? Well, because the government said so. Okay, I did service work for 100 years, doing just what you guys do. Thing is, until later in my career, we didn't have cell phone with fancy, pretty cameras. I mean, I did have cell phones when I worked in the field back. We had flip phones. Anybody remember the old Nextels, the big bricks? Anyways, when you get a model number, you're going to call here for a part. This seems like a really stupid thing to talk about, but Dave and I and the others, a lot of times are defusing problems that shouldn't have happened because somebody got the wrong part. Okay. That entire big lengthy part number, model number means something. So when we say we need the product number, and you got, oh, it's a 582 8-ton. Okay. That didn't tell me anything. We're going to look at that. We need that whole lengthy number. The serial number would be good too. Because everything in that number means something. Now, our guys are trained to get you the part you need. All right. So if you come in and don't give them all the right information, we're going to try to make some assumptions, right? And blower motors especially. So we have a standard static unit, a medium static unit, and a high static unit. So that one of those numbers, that one right there, tells me what blower's in this thing. If you don't get that whole number, and our guys say, well, in this one, we normally stock the high static, they're going to give you their own motor. They're going to have to guess. So get that entire number. It all means something. This is our parts lookup screen. Doesn't mean much to you guys. However, if I plug this in, these are all blower motors, all different VFDs, fan options for the same unit. Okay. Before 49 to 17, after 49 to 17. Single speed, 2-speed, medium static, high static, low static, standard static. So all those numbers mean something. Okay. So please get the whole number, get your camera out, take a picture of it. All right, we do need that whole number because we do get a lot. That happens not a ton, but it does happen. We're getting a call. Well, this blower keeps kicking out. As we start doing some research, you got the wrong blower motor. The blower motor for the VFD is not the same blower motor for that same unit without the VFD. The one with the overload on it. So if you get a 2016 rooftop unit didn't have VFD on it, the blower motor is different than the 2017 that did have the VFD. The blower motor for the VFD does not have an overload. The one without it does. And that overload will cause the VFD to trip out. So again, that something as serious, simple as that serial number would make a difference, and it happens. You know, and it might be a $300 blower motor. You've already installed it. It's not going to work. So please, the whole number. All right, so we're going to run down the line here. This still says the 581 and 582K, the 581 and 582L. None of this has changed, okay? So this is the small chassis, 3 through 6 ton. Okay, you're probably familiar with this by now. We went to this Axion or Blue-On fan, as Kerry calls it, which is a ECM motor like this. Okay, love or hate it, this is what we have. Okay. All right. One of the reasons they went to that big part is 2-speed, pretty simple to do with an ECM. ECM is way more efficient than a PSE motor, right? Or a 3-phase standard motor. Okay, so it all had to do with efficiency. There's no belts. This is really easy to set speed on. All right, we're setting static. We don't have to screw with pulleys. So there's a lot of great benefits to this motor. Now, if you guys have worked with these, you've had failures, you're like, that motor suck. Well, generally, 95% of the failures we get with these, like any other ECM motor, are power related. Okay, and it's a challenge for us. I know, I've been out there. Well, my other unit ran for 30 years. Changed filters, right? And this thing's eating blower motors. When we start digging into the power, they got power problems in the building. Well, the old unit with the contactor didn't care. This one does. Okay, so we'll get into some of the things we can do with power problems later on. Okay, they're not going away. You know the difference between a VFD, an ECM motor, and an inverter on a mini split? Nothing. They're all exactly the same thing. They're all doing exactly the same thing. So basically, there's a VFD built into the module of this motor. The thing driving a mini split technically is not an inverter, it's a VFD. It's doing the exact same thing. So it's all the same thing. So love it or hate it, it's not going away. All right. It's a matter of time where we're going to have variable speed compressors on everything. It's coming. So we just have to learn to deal with it. Okay, so we're going to look at this motor here. Again, all the rooftop units have standard static, medium static, and high static. Okay, most of the time we're on the bigger units, we have the medium or we stock the high. On the old belt drive motors, if I had a medium static unit and I needed high static, I could change a blower motor. That doesn't work with these, okay, because it's not just the motor that's different. All right, the entire assembly is different. The wheel's different, the motor's different, so it's not so easy to move a medium static unit and convert it to high static. Okay, so the larger units, so this is the 7.5 ton to 15 ton. Okay, some of the other changes when they converted to this. Okay, we got rid of the belt drive. We went to the ECM, single ECM motor. We've gone to a TXV. All right, so they've eliminated those flow check, those AccuCheck valves. Is everybody familiar with those? We used to have little orifices in the header. All right, we got rid of those. All right, they've gone to all TXVs now. So that was one of the other big changes on this, besides going to the blower motor. Okay. I'm sorry, that's the 3 through 5 ton. The 7.5 to 12 ton, we've gone to two compressors. Now, it's a single circuit though. Or does everybody know what I'm talking about? It's not 2 compressors, 2 condensers, 2 evaporators. It's 2 compressors, 1 evaporator, 1 condenser. So those compressors are piped together. They're manifolded together. Now, unlike some of the other companies who've done this, including BRYANT in the past, those are 2 separate compressors. So you can order them separately, even though they pipe together. All right. Also went to the TXV. We eliminated the flow check valve. We went to the TXV, went to the ECM motor. And then we get into the big 17.5 to 27.5 ton unit. And we've gone to 2 of these. Okay. We've also gone, like I said, to the TXV. So we've got a TXV across the board now. And we went to the 2 blower motors. The blower motors are in a tray. So you slide the whole thing out. Okay. If you've never taken one of these out, you can see the 2 screw holes here. So this slides in this way. You remove 2 screws, it slides out. Okay. 5/16 nut driver. You take 8 screws out here. That pops off. Take your 8 screws out. The blade comes off. You flip it over. There's 4 screws. This shell comes off of it. This plate right here, does everybody see this? Okay, that is a heat shield. When our people look this motor up, it'll tell them in our parts lookup to give you this heat shield. We don't stock that heat shield. Because I don't know if you saw that email from Jean yesterday, that she's looking for a heat shield. There's 3 screws. You reuse this heat shield, so take it off the old motor. Okay. But that's pretty much it. This ring is part of this assembly, so if this ring breaks, we need to replace it. And yes, we do stock this ring, but it is part, and if without it, it's not going to move the right amount of air. And make sure you snap it in completely, because we have had one of these rings that I've seen, didn't get snapped in all the way, and it actually tore it apart and whipped it around inside, and it made a mess of the evaporator coil. So make sure you get this snapped in goodly. Okay. Well, I must have had my hand on the button there for a while. Okay, so the big units, they come out in a tray. Now, anything over 6 ton, there's a safety circuit tied to these motors. So we'll see in a little bit where that safety circuit is at. Because these are sitting on top of the heat exchanger, they don't want this furnace to fire without this thing running, right? Because you're going to melt these blades. So there's a safety interlock on the 7.5 up to 27.5 ton unit. So if that motor fails, it's not an overload, it's a safety circuit. If the electronics in that motor fail, it's going to open a switch, will stop the unit from coming on. Okay. So when you have the dual fans, it has it, and when you have the single fans on the bigger 7.5 ton, it will have it. So if you walk up on a unit, it's not doing anything, just sitting there off, no 24 volts on RNC, it may be one of those blower motors. Okay. So, the central terminal board. Okay. Now, the old 580 for the last 20 years. Had this board. Right? The flat plugs. And this is just nothing more than a wire nut. This is a terminal strip, basically. Well, with the new Axion, we've gone to these boards, okay? There's 2 different versions. There's a single phase and the 3-phase. Okay. Something that's also missing from this compartment is there's one contactor, right? And this is important to know when we start talking about why we're frying motors. There's no contactor for the blower motor. That's the compressor contactor. All right. Why is that? So if we look at this here, here's a harness for this motor right here. Everybody recognize this? This is your wiring terminals, L1, L2, L3. And if I look, this is actually a single phase motor, so there's only L1 and L2. See the yellow and black wires? Okay. So if there's power on that disconnect, there's power on that motor. Okay, and this is where we lose these motors, because when we have a power surge, we have high voltage, we have low voltage, we have brownouts. There's nothing protecting that motor, all right? So there's power on it 24 hours a day. Okay, because we no longer have a contactor for it. All right, so what else is different about that board? Okay, we added this little dial here, and this is how we set the blower up. Now, I can't tell you how many times I've had an argument with a guy on the phone. Well, I put a new rooftop unit on, and it keeps eating belts. Well, did you adjust the belt? No, it came adjusted from the factory. No, it didn't. No, it didn't. No, it didn't. No, it didn't. Number one, they don't know what the static in your duct system is. And for those who don't know much about static, we're going to talk about that a little bit later on. But static's a really important thing. We don't know we got shitty ductwork, we got good ductwork, so they don't know. Not to mention that unit's traveled over 2,000 miles before it got here. The old belt drive units, you have to adjust them. You've always had to adjust them. This we also have to adjust, and if we don't, one of the reasons we're going to get motor failures is not properly adjusting these. We're going to talk about that in a second. Okay. So out of these two boards, there's a single-phase board and there's a three-phase board. The difference is the dip switches. Okay, the single-phase board you see up there has 7 dip switches on it. The three-phase board only has 2. Okay. If you replace the board, we need to put the dip switches back to where they were. Okay. Remember when I said we have a standard static, a medium static, high static? Those dip switches tell the single-phase unit what blower's in it. So simply put the dip switches back to the way the switches were on the old unit. Or if you look on the cover of the control compartment where your wiring diagram is, it'll show you where the dip switches go. So put them back.
They're preset.
Not with the replacement board, but in the unit, yes. So when the unit's delivered originally, yes, they're preset. Okay. So the single phase has 7. These 5 here have to do with how that, what blower's in that thing. So just put them back. If you took the old board with you, you forgot to bring it back with you, look on the tag by the wiring diagram, and it'll tell you where the switches go. Okay. Now we're going to, and this is kind of how it lays out. So for instance, we got a 5-ton standard, medium, high, and the switches go in different positions to tell you to tell the unit what size unit it's in. Again, this is only a single phase. All right. Now, it also has this bank of 2 switches here, and the 3-phase has that same bank. Okay. Remember I said by that ASHRAE standard, we have to have a 2-speed blower? This is going to tell the unit what to do with that blower in low speed, meaning R to G, circulation, or low speed cooling. Okay, out of the factory, it will be set for 66%, so both switches will be turned on. All right, I want to eliminate that for whatever reason. All right, we need more airflow during circulation. I can simply turn those switches off and bring it up to 100%. Okay, so you'll notice when this thing comes out of heating and the blower shuts off from heating, and all of a sudden you hear the blower slow down because it goes to that circulation speed. So the other set of dip switches, which both boards have to do with what the circulation fan speed is, the R to G. That as well is on the tag by the wiring diagram. Okay, so again, the first ones, make sure we put them back. These, we probably would put them back, but in the event we did want to eliminate that low speed circulation fan and go to high speed all the time, turn those both off. When you set a dip switch, you always have to cycle the power. All right, if you flip the dip switch, it doesn't change anything until you cycle power. Shut the power off for at least a minute or 2 because we have to let the capacitors on the board discharge or the change won't take. Okay. So, start that way. Okay, now we're going to talk about setting this blower up. Okay, it is not factory set. Okay, if you don't set the blower up on this thing, remember that safety circuit that I said was inside this motor? If it decides that it's drawing too much amperage or it's drawing too little, whatever, it will shut itself down. It will open the safety circuit and shut itself off. It doesn't mean the motor's failed. So the first mistake you make, and how do I know this? Like most everything we learn is in the field, right? We learn by on-the-job experience, meaning we got paid to screw somebody else's stuff up, right? That's pretty much what it is. So I admit, I learned this way myself. Out on the job of the contractor, motor's bad, we change it out. The new motor was wrong voltage. It was a 3-phase, we had a single phase. So we put the old motor back in, and just for the heck of it, we turned it on and it ran. Well, wait a minute, it wasn't running before. Because what I didn't know was it had been shut off on its safety circuit. So before you fault one of these motors, first thing you want to do, throw the disconnect for 3 minutes. We are service people. We have no patience, right? I have really little patience. 3 minutes seems like an eternity. Look at your watch, because the capacitors inside this motor have to discharge before it'll reset. 3 minutes. Turnabout disconnect down. Oh, the motor's running. There's nothing wrong with the motor. There was a power issue that caused the motor, or the static was not set up. Okay, the static pressure wasn't set up correctly. So, this tag is also on the control box of that unit. And it's going to tell us how to set the static on this unit. Okay. Before we set the static, what is the first thing you do on a rooftop unit when you turn the disconnect on? Very first thing. Check the primary voltage going to the transformer. Does everybody do that? That's a multi-voltage transformer. It's either 230 or 208. And it's tapped from the factory at 230. If you have 208, guess what happens? I don't have 24 volts. I have 22 or 21, 23. I have low voltage, and I start eating contactor coils. First thing, power up. Check the primary voltage going to the transformer. If it's 208, you want to change the wiring on the transformer for 208. Okay, if it's in the middle, let's say it's 212. Well, which way do I go, 230 or 208? Try it both ways until you get the highest output on your transformer. Is everybody following that? Okay. Because what will happen, it'll work. But in 6 months, your service guy's back because the contactor coil's fried. All right, so that's one of those things that might not show up right away. So make sure you do that. All right. So first thing I need to know, what is my CFM? So what is standard CFM per ton? 400, right? It's been like that forever. Yeah, in some cases we might go to 350, we might go to 450, but the standard is 400. So if I have a 5-ton rooftop unit, how many CFM is it? 2,000. 5 times 4, 20, so 2,000 CFM. So down this side of this chart, you can see there's CFM. Okay, so it's a 5-ton unit, 2,000 CFM. Across the top is static pressure. Now, does everybody have a manometer? If you do not have a manometer, you should have a manometer. You know, back in my day, and I'm going to date myself, and I'm going to date some of the other guys too. Anybody remember the incline manometer with the Dwyer with the red oil in it? Very accurate. But for those who don't remember, it was a big plexiglass block, and it had a ports drilled through it, and you had a special oil with a special specific gravity, and it was a manometer. And what happened is every time you go get out of your truck, all the oil had dumped out on the floor of your truck. Okay, we have digital manometers now. All right, if you're using that little dial thing, don't use that. If you want to use the old-fashioned water manometer, still accurate, but you should have a digital manometer. All right, they're inexpensive now. We didn't have these when I first started, but that should be one of your second or third meters you should buy as a manometer. Okay. We use it for gas pressure. We're going to use it for static pressure on duct systems. We're going to use it for pressure switches. So it's got pretty many uses. So we're going to use our manometer to check the static. We're not going to guess, okay, because we're going to end up with blower motor problems. So now, if you're just an installer and you don't care about your service guy coming back 3 times over the next 2 years trying to figure out why the blower motor keeps quitting, then this doesn't apply to you. But hopefully you're a little bit more concerned than that. So, 2,000 CFM. Everybody know how we figured that out. And if you're not sure what tonnage the unit is, it's always one number less than what it says on the tag. I don't quite know how that worked out. But for instance, a 582 KE04 would be a 3-ton. An 05 would be a 4-ton. An 06 would be a 5-ton. An 08 is a 7.5. Okay. So we can figure out a CFM. Our static, we're going to talk about how to get that. It gives me a number, 9.7. That is where I'm going to set the dial on this. On the board here, I'm going to set this dial to 9.7 volts DC. Now, the bigger units, so this is the 7.5 unit and up. And that goes from 3,000 to 5,000. This is up to the 27, 6,000 to 10,000. So it's the same basic procedure. Okay. So how do I get the static? This is the key. You know, and if you don't know how to do this, it's okay. A lot of us were never taught how to do this. It's actually pretty simple. New construction, right? Well, the engineer says he designed this duct system to 1 inch of static, right? Do we trust that? No. No, because we know it never went in the way it was designed. So we have to actually check it. Could I check the old unit? No, because again, it doesn't matter. That was the old blower, whatever CFM it was moving, we don't know. So we're going to get our manometer. Not one of these. This is fine if you still want to use one. Magnehelic, another one you might see a guy use as a big gauge like this. But a digital manometer you should have. Okay, duct system. What is static? So when I'm forcing air down a duct system, okay, every bend, every transition causes a restriction, trying to keep that air from moving. And the more restriction in the ductwork, the harder this motor has to work to push 2,000 CFM down the ductwork. So we're going to measure that resistance, static. Okay, and that's going to tell us what I need to set this thing at. So it's actually really pretty simple. This is not something you got to get off for, I don't quite understand. Static is resistance to airflow. So I need to measure it. Now I have 2 duct systems. I have a supply duct. I have a return duct. I have an air filter. I have an economizer. I have a curb adapter. Curb adapter, don't miss the damn curb adapter because sometimes those are really stupid high static. So we're going to take our fancy meter, and I'm not pushing the field piece meter specifically. I do like it, however. And you're going to have your static tubes. Now these are not pitot tubes; these are single tubes, but they're shaped like an L. Point them into the airflow. So this is a dual manometer. I'm going to check them at the same time, or I can check them individually. The return will be a negative because it's sucking air. The supply will be a positive. We don't have to remember how to add positive and negatives. We're just going to add the 2 numbers. Drop the positive and negative. We don't care. Just add the numbers together. So face the tube into the airflow. So I got 0.5 inches coming out of the unit. I have 0.4 going into the unit. 0.4 on the return, 0.5 in the supply. Now, where do I do that? Can I stick that probe in the door of the unit? No. And sometimes this is where you will see an air balancer do this. Okay. We are all here for a reason, right? Why? Because we're technical people. We can't sit behind a desk, right? That's just not the way our brains work. But we need things to be shown to us, right? Because we don't believe things unless we see it. We see the air balance guy, and I've seen him many times, and I used to do this myself. So we go to BRYANT about 4 or 5 years ago. They have a rooftop unit sitting on a curb. They have the probes in the door, and then they had us put the probes in the ductwork. And it was about a 30% difference. So it's huge. So you cannot put the probes in the door to measure static. You got to go into the ductwork in the drops. Okay, now my ductwork's above the ceiling here. This is not easy to get to. So ideally, new construction especially, you want to do it when the unit first goes in, when you can get to it. Okay, so in the return and the supply drops. We got to get into the drops, not into the unit. Those readings will not be correct. So I got 0.4 on my return, 0.5 on my supply, drop the negative, drop the positive, add them together, 0.9. So we have 0.9 inches of static. Curb adapters. Okay. When you get the curb adapter, there should be a document that tells you what the static is. The engineers figured it out for you. I had a curb adapter up north. We had a medium static unit on it, the old belt drive, and kept tripping limits. We couldn't get airflow. Well, we find out the curb adapter had 0.8 inches of static. That's a lot. Okay, the average commercial duct system is designed at about 1 inch, residential about 0.5. So it had 0.8 inches of static, meaning I had, and it's a medium static unit, meaning I had about 0.3 inches of static for everything else. So I was tripping. If you don't have it, if it's not on the document, then you either call your guy here or call Micrometal or whoever that curb adapter came from and get that static. Okay, because I'm going to be checking static in a duct system. I'm not going to be measuring that, right? So I need to know what that is. The economizer. Okay, if I look at the economizer paperwork, there will be static on there for the economizer. Now, if you look on this tag right here, they're already adding in for the economizer for you. So they're telling you on this unit, just add 0.1 for the economizer. So 0.9 that I figured in the duct plus 0.1 for the economizer. But it should be in the paperwork for the economizer. Now, somebody in here is not saying it, but they're saying, well, there's no paperwork coming with the economizer anymore, right? There's a QR code, and us old guys don't like this stuff. But if you scan the QR code, it will take you to the paperwork. It'll bring the paperwork up for you. And this document, this should be in there. Okay, so in my example we're looking at, I had 0.9 inches of statics. Everybody see how I did it? Pretty simple. I have an economizer. I'm going to just go with this number here and says, well, it says add 0.1. So I need, I have 1 inch of static. That's my total. Okay.
Then do you add the curb adapter?
Well, if I had it, I would add the curb adapter. Okay. So if I had 0.9 plus 0.1 for the economizer, in that example, I had 0.8 for my curb adapter, I got 1.8 inches of static. Now, this was a big, big unit, but I'm almost at 2 inches of static right off the bat, which there's no system, there's no blower we sell that's going to handle 2 inches of static. Okay, so 2 is kind of the limit. You can get slightly beyond it, and so you can get some high static systems, but I'm talking about your typical rooftop unit. So, coming back to this thing here, we have 2,000 CFM. We figured we had 1 inch of static, right? I had 0.4 in the return, 0.5 in the supply, add them together, I got 0.9. I get 0.1 for the economizer. I just took that from here. So my total is 1 inch of static. Everybody see how I got it? So 1 inch from here, 2,000 CFM, 9 volts DC. This is DC voltage. Now when I pass that board around, there's what looks like 2 female spade connectors right here. And they're marked VDC, volts DC. If you take your meter, put it on DC. This is important because on DC we don't have hot and neutral, we have positive and negative. So positive is red, black is negative. If you reverse your leads, you're going to get a negative reading. Red lead on positive, black lead on negative. There's a switch here that's going to get us into a range, okay? So when I look at this here, I have a switch ABC, it's right here. A is 4.1 to 7.5, B is 6.9 to 8.7, C 7.7 to 10. That's volts DC. So my range is 0 to 10. So I needed 9, so I put the switch at C. All right, so I flip the switch to C. Now, we do not just crank this thing up all the way because you're going to end up with blower problems. So now what I'm going to do, the blower does not need to be running. The unit just needs to be powered on. So I don't want the blower running to do this. I need to do it, the blower running for the static, but to set this. Power on, I'm going to turn this dial until I get 9 volts DC on my meter. Okay, the blower is set up. Okay, that's all I got to do. But I do have to do this. All right, because so many times we even go into jobs and it's set at 10 because, you know, they didn't have airflow. They hit the switch to C. They set the thing to 10. It runs. The motor keeps cutting out. They think it's a problem with the motor. All right, so does this make sense to everybody? You can't skip this step. Oh, I can't get to the ductwork. You have to get to the ductwork. Okay, you just have to. This is our job. This is what we have to do. Okay, don't go through the cabinet because, again, if I went through the cabinet from the examples I've seen physically, we might be from 0.7 to 1.3, so that's quite a swing. All right, so don't go through the cabinet.
Hear people's brains saying, all right, well, if I'm measuring in the ductwork and I get my, 0.8 inches of static, do I have to consider the curb because I'm already measuring in the ductwork and isn't that showing me all of the static?
That's a good question. And if we go back here, so the curb adapter, so when we're measuring here, we're measuring from here down, right? We're not measuring back up here. So the curb adapter would be up here, just like the economizer's up here. So that's why we have to add them because we're measuring in the ductwork below the curb adapter. So we're not measuring the curb adapter. If we measured up above the curb adapter, we're not going to get correct readings, but we would get the curb adapter. So good point. You're not, when you're measuring the ductwork, you're not measuring the curb adapter, you're not measuring in the economizer. That's why we have to add them. Okay, yeah, because we'd be measuring down here, unit be sitting up here, so whatever this is adding, we wouldn't know unless we measure it in the unit, which we can't get an accurate reading in the unit because of turbulence. Okay, last but not least, do the next guy a favor. Maybe it's you. Write down that voltage right here. Because guess what? You did it. It's a new steel construction site, right? By the time a year goes by, somebody goes back there to drop ceilings in. Now they got to get a ladder up there to measure it. Sure, it'd be nice if you wrote it down for them. All right, so write down the static, set it. If you go up onto one of these units and you're having blower issues and that switch is set at C and that dial is turned to 10, it was never set. And that's probably why the blower's cutting out. Okay. Any questions on that so far? All right. So when we talk about static, like I said, residential, usually 0.5 is our design. Commercial, we could be 1 to 2 inches is a pretty typical. So when we look at a medium static, or standard, medium, and high, that's how units are ordered. It has to do with the blower. So when I look at this chart, now every rooftop unit we sell has this chart, which is a great tool right here. Again, Service Tech app. Pull it up on your phone. I'm having airflow problems. What is this unit even capable of? Service Tech app. You pull the product data. I'm looking at the unit. This is a 7.5 ton unit. The gray is standard and medium static units. The dark gray is high static units. Remember, the difference is going to be the motor, the whole blower assembly. So let's say I need 3,000 CFM. And I have 1 inch of static. That works. But what if I have 1.6 inches of static? Okay, this is the max that standard static unit can do, is 1 inch. So what happens if I have over 1 inch? I'm no longer moving enough air. And now the blower is going to be cutting out. Okay. Anybody ever have a blower wheel blow apart or seen it? That's usually what does it. I got a standard static unit and I get too much static on it. Airflow issues. If I'm having airflow issues, coil's frosted up. Limit keeps tripping. It could be your duct system is too much static for your unit. And if I did my static, okay, my static's 1.6, I pull the document on this unit, well, shoot, it only goes to 1 inch on the medium and standard static. I have 1.6 inches. I'm not going to get 3,000 CFM. So I'm freezing coils, I'm tripping limits. All right. The high static unit is in dark gray. Well, hell, look at that one, has no problem giving me 3,000 all the way over to 2 inches. Okay. With the old belt drive, generally I can change the motor to go to a bigger motor. Okay. With these, it's a little tougher. Some of them, I would have to change the entire blower assembly, so I'd have to order all the parts for the high static unit. Okay, but this is a great tool when you're trying to measure airflow. Okay, because if you're not getting the airflow you're supposed to, and you got this thing set up to 10, I still can't get the airflow, this document here would tell me my medium static unit is not capable of running against 1.6 inches, right? So I may have to do something to this duct system to reduce the static. All right. I might go to sweeping bends. I might add in turning vanes. There are a lot of little tricks we can play, but we may have to correct that. Okay. But if we got this condition, we have to do something about it because that motor will never run. So if you're having a motor problem, this chart is tremendously helpful. Okay. The one I talked about with the 0.8 inches of static with the curb adapter, I went to this chart. I could plainly see my problem, and you can see what happened is the motor horsepower changed. So I was able to go to the high static motor. It was belt drive, and I was able to change it, and the unit worked out fine then. This one is a little different, right? Because I can't just change the motor because the motor's different. Okay. So troubleshooting this thing. This is really, really easy. once you kind of understand how they work. All right. You know, we get into ECM motors and even residential furnaces. You get the call every day, guys on a residential furnace with an ECM and he doesn't know how to troubleshoot it. Because we add electronics and we start to panic. Okay, it's not that hard. If I were to tell you I know exactly what goes on inside that motor and the electronics, I'd be lying to you. But I know what it's supposed to do, and I know how to check it. That's all we need to know how to do. So, if we go back to my harness here, okay, you can plainly see my terminals. So coming from my disconnect, that'd be coming in here, L1, L2, L3. Every Bryant carrier unit made, L1 is black, L2 is yellow, L3 is blue. Okay, this is out of a 3-ton single-phase unit. It has a single-phase motor. Some of them are 3-phase, so I'd have a third wire. So if I look at this wiring diagram right here, okay, there's that terminal strip right there. You can see on a 3-phase, L1 black, L2 yellow, L3 blue. All three go to the motor, and you can see there's nothing breaking it. If the disconnect is on, that motor's got power. Again, why, if I get a power surge, that motor's taking it. Single phase like this one, it's just yellow and black. Okay, because it's a single phase. All right, so obviously the first test of that motor is, does it have line voltage coming to it? Now, personal experience tells me, and I'll tell you in a little bit and you're going to laugh, why we don't check it here. If I check voltage here, it doesn't mean it's getting there. So inside the blower compartment is this plug here. I want to check it here. I want to check it on the motor side of this plug. Now don't unplug this and stick your meter leads in there. If you stick your meter leads in the face of that plug, I'm going to send Dave out there and he's going to slap you. Okay. You want to, because what will happen, you'll destroy those contacts. And I'll show you a picture of something happened just that. So, okay. Meter lead this side. So if I flip this over, here's my black and yellow. Black is L1, yellow is L2. I'm going to put my meter leads in the plug side, the wire side of this plug. Okay. And I'm going to check for my line voltage. Okay, so if I check here, yeah, so right there. Because now I'm seeing what the motor's getting, because what if these contacts are damaged? And I've had it happen. So we're going to check it here, because now I can see that motor's really getting 230 volts, right? So I know this contact is good. I know this contact is good. And if I don't have power here, I'm not going to have it here either. So if I don't have it here, I might have to backtrack. But I'm going to check it right here. Okay, wild leg. Does everybody know what a wild leg is? If you don't, a lot of older areas, especially industrial, they had what was called a wild leg. So I go L1 to ground, 110, L2 to ground, 110, L3 to ground, 208, 210, called a wild leg. Stinger leg. If you have a wild leg, it has to go on blue L3. Okay, it has to go on blue L3. Why? Well, I asked that question too, and they gave me what sounds like a legit answer. I'll take their word for it. First thing we asked is, why do I have to go to blue? Because the first thing that happens when this 230 gets into this motor is it's converted to DC. And then that DC power powers all the electronics in here. They don't want the wild leg going through the electronics, because that could cause this motor to fail. So if you get one of these motors, it's been replaced twice. See if you got a wild leg, and if it's on L2, you want to move it to L3. Okay. Now, I'll warn you though, and think about this for a second. If I go up on a unit, been around for 2 years, but I've bought 3 blower motors. Geez, I got a wild leg in L2. Well, I'll just go over my disconnect. I'll move it to L3, right? Everything's good. What did you just do though to your compressors? I just reversed the compressors. That motor is going to spin the right direction no matter what. Okay, so if you are used to looking at your blower motor to see if your compressors are spinning the right direction, you're doing the wrong thing, because that's going to spin the right way. No matter how many times you swap the phase, that motor is going to spin the right direction. So if you got wild leg to L2, you're going to go to your disconnect and you're going to swap L2 and L3 to put the wild leg in L3. And then you're going to swap L2 and L1. Why? Well, the first swap reversed my compressors. The second swap would put them back. So is everybody following what I'm talking about? Because when I swapped one of the two legs to put the wild leg from 2 to 3, I just reversed my compressors. So now I got to swap 2 and 1 to put them back. Run them to make sure you got them right direction. Okay. Is everybody following? Yeah. Normally, it's not going to cause the motor to seize. No, you're going to fry the internals. Okay. Yeah, well, like this, you can't quite see it still, but this thing was, it's been bounced around. You can see how filthy this thing is. Okay. Obviously, dirt. These are sealed bearings. So there's nothing to moisture could be doing it. These are not makeup air units. You're only allowed so cold to return air on these things, and guys will try to use them as makeup airs, and you're dumping, day like today, you're dumping all that cold air, that motor is going to condense. So it could be something like that. I mean, I'm guessing, I didn't see it. Or it just could be a bad motor. It happens. Okay, these motors are actually made in Germany, so, German engineering, they're supposed to be really good. So, but for the most part, we haven't had too much problem. And most of them that we've had repeated failures, either once you guys worked through them or we went out there with you, we figured out where the problem was. Okay. And we got power problems all over the place. Okay. And we'll talk about, that's one of the last things we're going to talk about, power issues. Okay. So, again, wild leg on blue, which is L3. So this is really kind of cool once you know this. This yellow wire going to this capacitor, guess what? That's L2. Okay. This black wire right here, that's L1. So anywhere in the unit where you see a yellow wire, it's L2. Any black wire is L1, and any blue wire is L3. Transformer, red. The common is brown. So if I'm trying to pick up 24 volts anywhere, I found a brown and red wires, 24 volts. Okay, so first of all, L1, L2, L3, I have power at the motor because I have had damaged connectors to where it doesn't carry through. Okay. Now, the way this thing works. All right, I want everybody to be clear on this. The motor takes 230 or 460 and it creates 10 volts DC. In the electronics in the motor, it creates 10 volts DC that it sends back to this board. So remember when we turned this little dial here? We're adjusting that 10 volts DC. So up this orange wire, you got the other end here, we got orange, gray, and white. White is negative. Okay, so think of common, like you would with AC volts. So orange is 10 volts coming from this motor back to my board. Okay. I adjusted it, and when we set it up, I took it from 10 and I set it to 9, because that's going to affect the blower speed. So on a call for this blower, it's going to send that 9 volts back down this gray wire, and the motor should come on. So in theory, if I were to jump the orange and gray together, I'm sending 10 volts DC to that motor, and the motor should come on. Right? I could put a jumper right there, and that motor should run up to full speed. So the next half of that test is motor's on, meter on DC. I'm going to again start at the plug here. And there you can see the orange and gray and white wires. And I'm going to take my meter. Again, the white, which you think is negative, so I'm going to go from white to orange. I should have 10 volts DC. If the motor is powered, we just checked it, right? It's 230 the motor. Then I should have 10 volts to that orange and white. If I don't have 10 volts to orange and white, the motor could be locked out. So remember, reset power, 3 minutes, turn it back on, check it again. If I still don't have 10 volts DC, guess what's wrong? The motor's bad. Okay, the rectifier inside the motor is bad. So we're no longer creating DC volts to turn it on, so this fried. Okay, I do have 10 volts to the orange. So we're going to call for blower, right? So I'm going to R to G, put a jumper R to G. And what should happen on the one we just set up? I should get 9 volts back down the gray wire from the board to tell the motor what speed to go. So if I go from white to gray and I have 9 volts, when we're calling, the motor should be running. Again, if it's not, shut it off for 3 minutes before you fault it. But if I have 9 volts going to that gray or whatever that dial set at, the motor should be running. Okay, so it's pretty simple to test. Okay, I can actually do it at the board as well. So you can see the orange wire and the gray wire. So I can, remember negative is the bottom, so that would be white, so I can put my meter in negative. I can check the orange, I can check the gray. Powered up, I should have 10 volts on orange all the time. On a call for blower, whatever that dial set at should be going down the gray back to the motor to tell it what to do. If I jump those two, the motor should come on. Make sense? It's really, really simple once you understand how to troubleshoot the things. Like I said, if you don't have either, you don't have 10 volts DC, or you have the voltage coming back to gray and the motor's not running, cycle it off, 3 minutes, let the internals reset. It's not an overload, it's a safety circuit.
You ever had the board side fail?
Yes. Yes. Okay. Unlike the old 580, this is the old belt drive board. There's no logic on this board at all. There is a relay circuit down here. So every furnace, every rooftop unit you guys have ever worked on, there's a relay on the furnace control board that when you energize R to G, turns the blower on, right? Okay. When we get to the gas control board, ooh, look, there's two relays. Low speed, high speed. G, Y2. Either way. Okay, so there's still a relay on the gas board, but there's a relay on here too. So go back to your question. If I got my 10 volts DC there, I jump R to G, I don't have voltage coming down the gray. I come back here, because it's not the motor then, right? So that means it's not coming here. So that means either this relay is bad or this is bad. So you can simply go in, again, pull up the Service Tech app, get the document, or you can look at the wiring diagram. And there's one wire coming off of here from these relays, and I think it's the black wire that you can follow straight down to here. So what I can do is I can check, do I have 24 volts on that blower wire here? Yes, that means this is calling, this is not running, so this has got to be the problem. Make sense? So these relays still are flipped by the thermostat, but there's also a relay in here. Okay, so to answer your question, yes, this could be bad. So yeah, if
Just a handy little tip, a lot of the contacts on the newer boards, especially if you're doing the mini splits, are all a lot smaller. So if you don't already have needle probes, make needle probes for all of your meters. Get a set of those, because it's a lot easier to get in there and actually make contact than trying to cram your big lead into the back of one of those.
good point. So yeah, here's the logic that's on that board. An IFO here. Okay, and there's actually an IFO terminal. That goes to the gas board. Those relays from the gas ignition board, indoor fan. That's what's coming into here. Okay. So again, 10 volts DC, orange all the time. On a call, I should have voltage on the gray. If I do, the motor should be running. If I don't, that means either this has failed or this has failed. So I can come back to the gas control board, check, do I have 20 volts on the IFO terminal, which is the indoor fan output. If I do, then this board is bad. If I don't, the gas control is bad, which I don't know if you've seen it. Every so often we'll get a crack in I've had it happen, you got a crack in the solder, and you push on the board and all of a sudden the blower comes on. And you look on the back and there's a little brown spot where it's been overheating. Okay. So any questions on this? Really, really pretty simple. Again, kind of knowing how it works. Okay. So again, check it for DC. Should be 10 volts DC on orange all the time. So do you have 10 volts DC on orange? If the motor's powered up, I should. If not, reset power before faulting the motor. Otherwise, the motor's bad. Energize a call for blower, R to G. Do I have voltage on gray? If I do, the motor should be running. If I don't, the motor's bad. I mean, if I have volts DC and the motor's not running, the motor's bad. If I don't have volts DC, then I'm going to go back and look at the gas control board. Do I have the output from that? Like I said, if the motor's not running, kill the power for 3 minutes. And yes, be patient. We need to give it 3 full minutes for the capacitor to discharge. Okay. Last but not least, going back to what Dave said. Okay, and I'm not ashamed to admit my own errors. This bulletin here on the right, I did that. When we first got this unit, I was on a job and one of my contractors close to the shop, close to my office, had put one in, and what they're showing is where this motor plugs into this board. So right here, you can see my orange, gray, and white wires. They plug into the board right here. Like Dave said, and like I was saying earlier, always check where the wires go into the plug. So you might have to get some needle leads. So what Mr. Contractor had done is the motor wasn't coming on because he didn't have it set up right. So it kept cutting out. So you unplug this. Remember I said I have Dave come slap you if you stick your meter leads in the front? Well, he did. So that plug you see right there is this plug. And you can see he jammed his meter leads into the front of that, mushroomed them all out. Unit wouldn't come on. We just got in this line with this new blower. I'm on the phone with engineering. Dude, I got my voltage right here, just like you said. I got my 10 volts, and the motor's not running. And I have my voltage on the gray wire here. Well, guess what? It wasn't making it to the motor. So they proceeded to tell me to yank the unit, put another one on the roof, and they sent an RMA, and this went all the way back to Indy, and they tore it apart. The unit I took back, and so I should have caught that. All right, like I said, on the job training, right? Doing this for over 40 years, we still make mistakes. We still learn something. Okay, so do not stick your meter leads in the front of the plug. Okay, wire side, like Dave said, get you those little needle leads and get them in the wire side. And that's also why, because had I known then that I should, if I would have checked power here, I would have seen I was not getting any voltage on the gray. Okay, because this plug was not making contact. Okay, and I've had this, not this, I've had it happen on other terminals, same thing where the wire wasn't seated all the way, and if you go into the wire side, you find all that. Okay, any questions on that? Okay, so when we get into the larger units, like I said, the 7.5 to 12, and then the 12 to 17 to 27, we have the 2 in the bigger chassis, we have the single in the smaller chassis, but they also have added a safety circuit. This one here simply has gray, orange, and white, yellow and black. I do not have the safety circuit. This is the 3 through 6 ton. Sorry about that. So, when I look at the big units, they'll also have 2 red wires going to the motor. And that's the safety circuit. Like I said, it's not an overload. It's actually an electronic safety circuit. It's a normally closed relay. And I think when it's creating DC volts, it keeps the relay closed. And what it does is if for whatever reason it faults, it opens the relay, locks the motor out. So if I have to take this board and lay it on its side like this, okay? So you can see here, here's my board laying on its side. This plug right here is this right here. So this number 1 terminal right here, if I follow it back, it's coming from the transformer. Everybody see that? Now I will say something. As many years I've been in this field, I hate their wiring diagrams. I'm not gonna lie. I really, really do. I really hate them. But in 20 years working for BY, I still hate them. But so if I follow this, see the red wire, so off my transformer, does it go anywhere else? No, it goes right here first. Nowhere else in the unit. And it comes right to here, and I have my 3 jumpers. My jumpers for my smoke detectors right here. Okay. So, if I break any one of these jumpers, guess what? I just killed 24 volts to the whole unit. So that's why your smoke detector goes here, right? But I'm going to show you something. If I follow this first one here, it says 24 out. And if I find on the board, 24 out, this bottom one right here. If I pull this jumper, I still have 24 volts on that bottom terminal, right? Well, what's going to run my smoke detector? 24 volts. If I pick up 24 volts from the center of this board, guess what happens when my smoke detector opens? It kills it. So that bottom terminal is where you're going to power your smoke detector from. Everybody following that? One where it says 24 out? Because if I follow it, it goes right to the transformer. So your smoke detector is going to break this. So I'm going to unplug this jumper. And the reason I'm bringing this up now is because this, Kelly, goes back to what I said about changing things. I had a contractor call last week. We have a problem with our smoke detectors. Because when he's doing a smoke test, he keeps losing his 24 volts. So what was happening is he was using these terminals here, the RNC, and when he tests a smoke detector, it would kill all 24 volts and reset everything. So he thought there was a problem with the smoke detector. So where it says 24 out, the bottom one there, so it goes from here through this jumper, through this jumper, through this jumper. Then it goes back to the third terminal here, which is number 7, indoor fan motor. Oh, look at there. It goes through the safety relays in both fan motors. And it comes back on 7, and it goes to R. So what do you think it does then? Now it powers everything in the unit. So, if I got no 24 volts, you come up on the unit, I go to RC, I got no 24 volts. The first place I'm going to check, it starts right here. Go through these jumpers here. Is my smoke detector open? So I should have 20, I'm going to go through all these. And then from here, the next thing is the safety in the motor. So if the unit's just sitting there off, go look at the motor. Okay, do they have the red wires? If you don't have the red wires, it doesn't have a safety circuit. So you got the red wires, check to see if they're open. If that motor, and they might not be bad, maybe they overamped, they faulted out, they shut off, they kill 24 volts to the unit. Okay, so it's important you know how this works, because we get lots of calls on that. I'm losing 24 volts. Well, if we kind of see how the flow goes, because I got nothing R and C, so these jumpers, the safety switch, then to R. Okay, it's right there. And again, if you're doing a smoke detector, make sure you go to the 24 out to power the smoke detector.
Clear that he's talking about units that have 2 of these blue axles.
No, not just 2. The larger ones, 2. The single ones do as well. So the 7.5 ton and up have the safety circuit. Now, what Dave is saying, this is a 2-blower unit, so it shows a 2, but the other larger ones will still have the 2 red wires just to the 1 motor. And that was an oh, by the way, because their original training didn't tell us that. And I got a call from a guy, well, I got a 12 ton, and what are these red wires? Huh, they didn't say this, those weren't there. But guess what, they are. We call that an oh, by the way. All right, so that makes sense? Okay. Last but not least, before we jump out of this motor, we're going to go back to this. This is our dissipation board. Okay, and then we'll take a quick break. See, I could go for hours, but I know you sit me in a chair, I'd been asleep already, so I give all you guys credit for staying awake. It's exciting. It's rooftop units. Okay, so the good news is if you sat in on the residential training, you had to wire this. You sit in the rooftop unit training, you find out, yay, I don't have to wire this, it's already installed. Your installation is no different. Set it, power, check your transformer, set your static, we're good to go. This is already done. So, but I want to see where this wires in. Now residentially, we have to wire it in. Here we don't. So these terminals here, remember on our board? Right here? Okay, this here where your motor's coming in. That's where they're tying that mitigation board in. I'm sorry, dissipation board. So instead of the orange wire just going to here, it's also making a U-turn and it's going up to this new dissipation board. Okay. And then the black comes to here instead of the gray. And then the gray comes from here to the motor. So what it'll do is instead of like you're going to remember all this here. Instead of the gray wire here going to the motor, it's a black wire going to the dissipation board. Normal operation, it'll come through here. This relay will be closed. So my 9 volts DC would come up this black wire, down the gray wire to the motor. All right.
You said this is residential?
No. This is commercial. Like I said, the residential is the same board. We have to wire that one in. This is all wired in. This is the same rooftop unit. So yeah, I'm glad you brought that up so I could clarify. So that's actually this board. So from this here, remember we had the gray and then the orange? We still have the orange, but now the gray is it's a black, which comes to the dissipation board, and then the gray comes here as well. So what happens is on a call, instead of a gray wire there, we're going to have a black wire. Same difference, 9 volts DC, whatever we should have. But if I have a leak, if I have to mitigate the leak, you can see what it'll do is it can now take the orange 10 volts DC, send it straight down the gray wire to bring the blower on. Make sense? Okay, just so you kind of see how it's going to be wired in. And you're going to say, well, Dave said there's a gray wire. There's not a gray wire, it's a black wire. Well, now we have this mitigation board. Okay. A few more things on this and we'll take a break. We're going to finish up this Axion motor. So if you rewind to about 2019, on the side of our blower motor, there's a limit here, which is still here. This was manual reset, and this one is actually manual reset. So that red wire that goes to that safety circuit, it used to go right here. So if you have a red wire in a Bryant rooftop unit, what is it? 24 volts, right? Limits are purple. 24 volts is red. So if you have a 2019 or earlier, it will have this manual reset limit. And they're still there. You'll still come across them. I got a call on the one the other day. So on this unit, the 24 volts went through the jumpers for the smoke detectors and went to there. So you'd walk up, you got no 24 volts. Go look in the blower compartment. If you got an older unit, it might have that limit in there. Reset that limit. Now, if that limit tripped, something happened because that unit's been running since 2019. And if it's tripping now, there's no point to take that limit out. Okay, because what we have now is a auto reset limit. Okay, so the units today have an auto reset limit there. And guess what? They're no longer red wires, they're now purple wires because they're in the limit circuit. Okay, but just know if you got one of the older units and you got no 24 volts and you got a 20 or earlier in 2020, go look, see if you got the manual reset limit. Reset it, figure out why it tripped. Okay, but they eliminated it. This red light on here, okay, if you have power that coming through the smoke jumpers, through that safety circuit, that light will be on. If that light is not on, I got a blown fuse on the board, or that safety circuit's open, or a smoke detector's open. Okay, there was a bulletin to replace that limit with a auto reset limit. Like I said, I didn't give you that bulletin now because if that unit's been running since 2020 with the manual reset, leave it alone and figure out why it's tripping. Okay, you're putting a Band-Aid on another problem if you try to change it to auto reset. So at this point, I wouldn't suggest that.